Dear students, today we will define a very important term in computation of discrete Fourier transform. That term is twiddle factor. Or phase factor Wn. In computation of DFT, we have used a complex exponent e raised to minus j 2 pi by n. This is nothing but a twiddle factor denoted by Wn. Wn raised to kn means e raised to minus j 2 pi by n whole raised to kn. By using laws of exponents, which I have taught in very first class, e raised to minus j 2 pi kn upon capital N here Wn is nothing but twiddle factor. So in computation of DFT, in place of e raised to minus j 2 pi kn upon capital N, we can make use of Wn to the power kn. Therefore, DFT of x of n is equal to DFT of x of n is equal to summation n equal to 0 to n minus 1 x of n into Wn kn. So here DFT of x of n is n point DFT for k equal to 0, 1, 2 up to n minus 1. Up to n minus 1. For n equal to 4 and L equal to 4, where n equal to 4 tells us we have to compute 4-point DFT, and L equal to 4 tells us the length of sequence x of n. DFT of x of n is equal to x of k, that is equal to summation n equal to 0 to 3 x of n into, now we have to substitute for n equal to 4 and keep kn as it is for k equal to 0 to 3. If we expand this, x of 0 will be equal to x of 0 into W4 K0 N0, product is 0, plus x of 1 into W4 K is 0, N is 1, but product remains 0. So you get 0 only. Similarly, x of 2 into W4 is to 0 plus x of 3 into W4 raised to 0. Since a raised to 0 is 1, x of 0 will be equal to x of 0 plus x of 1 plus x of 2 plus x of 3, which means that for k equal to 0, that is first DFT coefficient may be calculated as the sum of all the discrete values of given sequence. For k equal to 1, x of 0 W4 is to 0 plus x of 1 into W4 raised to 1 plus x of 2 into W4 raised to 2 plus x of 3 into W4 raised to 3. X of 2 is equal to x of 0 into W4 raised to 0 plus x of 1 into w4 raised to 2 plus x of 2 into w4 raised to 4 plus x of 3 into w4 raised to 6. Last coefficient of 4-point DFT, x of 0 into w4 raised to 0 plus x of 1 into w4 raised to 3 plus x of 2 into w4 raised to 6 plus x of 4 plus x of 3 into w4 raised to 9. So x of 0, x of 1, x of 2, x of 3 we got. Now these 4 equations may be written in the form of matrices. Let us see how we can write these equations in the form of matrix form. In matrix form, x of k is given by wn raised to kn into xn. So this x of k matrix may be now written as x of k matrix may be now written as x of 0, x of 1, x of 2, x of 3, and wn kn matrix may be written as wn raised to kn matrix may be written as 1, 1, 1 and 1. Here also 1, 1, 1, because you can see here in x of 0 the coefficients of x of n values is 1, because we are having w4 raised to 0 as coefficient for all the x of n values. Hence in matrix first row we will be having all the elements as ones. Similarly, if you go vertically downward, you will find W4 raised to 0, W4 raised to 0, W4 raised to 0, and here it is already 1. So first column will be having all its elements as ones only. Next we are having here W4 raised to 1, W4 raised to 2, W4 raised to 3, W4 raised to 2. Okay, in this way we can represent x of k Wn raised to kn and x of n matrices. Now we'll see what are the values of W4 raised to 1, W4 raised to 2, and so on up to W4 raised to 9. W4 raised to 1 means e raised to minus j2 pi by 4. 2 1 ja 2 2 ja. We get e raised to minus j pi by 2. E raised to minus j pi by 2. And e raised to minus j pi by 2 is cos of pi by 2 minus j sine of pi by 2. Minus j sine pi by 2. Cos pi by 2 is 0, sin pi by 2 is 1, so this becomes minus j. Once you calculate what is W4 raised to 1, the other values can be easily computed. W4 raised to 2 is nothing but minus j square. Is nothing but minus j square. Minus j square is plus j square, and j square is minus 1. W4 raised to 3 is minus j square into minus j. We'll make use of this minus j square value. That means it is minus 1 into minus j, that is nothing but plus j. W4 raised to 4, that means minus j square into minus j square. Minus j square is minus 1, that means minus 1 into minus 1, that becomes plus 1. Similarly, we can write for W4 raised to 6 and W4 raised to 9. When I do some small corrections here and there, I pause the recording but after doing the corrections I forget to press once again the record button. So here some lines have not been recorded. I will explain you. W4 raised to 6 may be calculated as W4 raised to 3 into W4 raised to 3, because W4 raised to 3 into W4 raised to 3 is W4 raised to 3 plus 3, that is equal to W4 raised to 6. But W4 raised to 3 is J, so J into J will become minus 1, that is W4 raised to 6 is minus 1. W4 raised to 9, 3 plus 6 is 9. So W4 raised to 3 into W4 raised to 6, that will become W4 raised to 9. W4 raised to 3 is J and W4 raised to 6 is minus 1. If we multiply these two we get minus J. So now we can put the values of various total factors in the matrix this way. 1 1 1 1 1 minus j minus 1 j 1 minus 1 1 minus 1 1 j minus 1 minus j. And here we have to write the values of x of n, that is x of 0, x of 1, x of 2, x of 3. If sometimes we have to calculate, say Wn Kn matrix, that is transformation matrix, complex conjugate, then that complex conjugate may be calculated as complex conjugate of individual total factors in the matrix. So this may be now written as one, 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 because these are real numbers, their signs will not change. 1, 1, 1, minus j will become plus j, minus 1 will remain as it is, plus j will become minus j, minus 1, 1, minus 1, minus j, minus 1, plus j. I give you a simple homework here. What is that? Is to calculate Wn Kn matrix for capital N equal to 8, for capital N equal to 8. This is homework for you. It is very much essential because in next class we will solve one problem based on this Wn raised to Kn. Today we will take one simple example to compute the DFT of a given sequence for capital N equal to 4. Take one example here. Compute four-point DFT of x of n, 4-point DFT of x of n equal to 1 0 minus 1 0. Using matrix method. Using matrix method. So here now solution follows like this. By definition, x of k is equal to wn raised to kn into x of n. So x of 0, x of 1, x of 2, x of 3 equal to total factor or transformation matrix x of n matrix product 1 0 minus 1 0. Please copy down this. And here you can enter 1 1 1 1 1 1 1 minus j minus 1 plus j minus 1 plus 1 minus 1 j minus 1 minus j. I hope you all know that how to multiply the two matrices. So matrix multiplied values are written here. 1 into 1 1, 1 into 0 0, 1 into minus 1 minus 1, 1 into 0 0. Next 1 into 1 1, minus j into 0 0, minus 1 into minus 1 plus 1, j into 0 0. 1 into 1 1, minus 1 into 0 0, 1 into minus 1 minus 1, minus 1 into 0 0, 1 into 1 1, j into 0 0, minus 1 into minus 1 plus 1, minus j into 0 0. Simplifying, we get finally 1 minus 1 0, 1 plus 1 2, 1 minus 1 0, 1 plus 1 2. So now you can understand how fast we have calculated the DFT of a given sequence by using the matrix method. Okay. Now you have to understand now we'll see how the IDFT can be written using matrix form. IDFT, that means inverse discrete Fourier transform. Know that x of n is IDFT of x of k. So this x of n is given by now 1 by n summation 1 by n summation k equal to 0 to n minus 1 x of k into e raised to j 2 pi kn upon n. But what is e raised to j 2 pi kn by n? E raised to j 2 pi kn upon n is nothing but complex conjugate of e raised to minus j 2 pi kn by n. So you can write this as 1 by n summation k equal to 0 to n minus 1 x of k into e raised to minus j 2 pi kn upon n complex conjugate. So 1 by n summation k equal to 0 to n minus 1 x of k into what is this e raised to minus j 2 pi kn upon n? This is nothing but wn raised to kn. So we can write wn raised to kn complex conjugate. And we know what is the complex conjugate matrix for n equal to 4. Writing above expression in matrix form, x of 0, x of 1, x of 2, x of 3 is equal to Triddle factor or IDFT transformation matrix capital X of 0, capital X of 1, capital X of 2, capital X of 3 product of the two matrices divided by n. And n here is of course 4. So this will become 1 by 4 1 1 1 1 1 1 1 1 j minus 1 minus j minus 1 plus 1 minus 1 1 minus j minus 1 j. So this is nothing but now x raised to 0, x of 1, x of 2, x of 3.